Good morning, students. Okay, you can continue your exam. If you are not completed, you can continue later. Now just listen here. Okay, we are talking about this. We are starting a new chapter, chapter 9, household circuit. Okay, we are continuing to chapter 9, household circuit. Okay, about this household circuit, most of the topics are already removed. Okay, we can take that second section. Section B, okay, section A is almost all topics are removed. Section B we are taking some essential components of house wiring system. Some essential components of house wiring system. So in this section we are mainly studying about this fuse and switch. Two important instruments used in the electric circuits and all, fuse and switch. Okay, first of all, what is a fuse? Actually, the fuse is a safety device. You know that it's a safety device. It's not any, doesn't give anything or any particular energy form. Energy conversion is not occurring. Actually, it's a safety device. Energy conversion is occurring. Actually, it's converting electric energy to heat energy, but it's a safety device. An electric fuse is a safety device which used to limit the current in an electric circuit. So, one more time, the fuse is a safety device which used to limit the current in an electric circuit. So, we can see this one. So, previously hope you remember that we studied about this power rating. Students, hope you remember we have already studied about the term power rating. The term power rating. Power rating means we have to see that 110 watts and 220 watts. It means if an instrument, if this instrument connected across 220 volts, it use 110 watts, it use 110 watt of energy in each second. Like that we have studied. This instrument will use 110 watt of energy in each second. Okay, like that we have studied. Okay, okay, students. Okay. Okay, students, clear. We can continue. So that's a power rating. From this power rating, we can calculate I. Normally, P is equal to IV. P is equal to IV, or I is equal to P by V is equal to I. Like that we have studied this. How much current through the instrument can be flow. Okay, just imagine. So in this case, it's 110. So 110 divided by 220. This becomes 0.5 ampere. Here the current rating is 0.5 ampere. It means for the proper working of this instrument, the current should pass through this one is 0.5 ampere. What happened if 3 ampere of current flows through this instrument? What happened if 3 ampere of current flows through this instrument? What happened if 3 ampere of current flows? Normally, current rating. Okay, students, remember the term current rating. Yeah, part A is removed. Want to study the construction and working? Yeah, just to go through it. No need to. Material fuse we already studied. Material fuse we already studied in previous section. Previous chapter we already studied. Okay, from that take the material. Okay, yeah, example needed. Example needed. Material you already studied. Then construction and working means no need much detail, just a rough idea. Okay, no need much detail, just a rough idea. Okay, mainly you need what we have discussed today, that's all. Why? See, most important question is why fuse should connect it in live wire. That's the most important question from this portion. Then working of fuse. Okay, see, fuse should be act if there is a short circuit or overloading. Okay, remember these 2 points. If there is a short circuit or overloading, then only fuse need to act. If there is a short circuit and overloading, then what's the effect? Current through the circuit increases. Current through the circuit means current through that equipments. Okay, current through that equipments. Current rating no need to by heart, but you have to know that current rating no need to by heart that table, but you know that the connector fuse should above than the required current of the equipments. Connector fuse, always select the fuse which always select the fuse have current rating above than the required current through the equipments. You need to by heart the value. Okay. 220. Okay, the table is not needed. So, see the current rating equation is needed. Current rating, total power P by V. We already discussed this. P by V, that is current rating. Current rating is basically P by V. So let's give that current that allow fuse to pass through it. Okay, so always connect the equipment. Always connect the equipment. Which is less than the power rating of fuse, like that only it will work properly. Okay. Construction no need too much detail. Okay, just okay. Actually, there I don't see any question from this portion. Holder, socket, like that. I don't see any question. That's why I didn't give much importance to that topics. Okay, so just okay, just read. That's all. I don't feel they will ask. Okay. Then, yeah, any more doubts? Yeah, diagram, explain with the diagram. Okay, live wire that explain with the diagram. Live wire, why fuse is connected to live wire, explain with the diagram. Okay, don't, after drawing diagram only you can explain. Okay, don't explain directly, don't start, first you explain with the diagram, draw the diagram first, then you can explain. Okay, I hope all the doubts I have answered. Any more doubts, students, about this fuse? Fuse, anything? Okay, then we can go to next section, that is switch. Okay, in the case of switch, have some similarity with the fuse also. Read the explanation and all. Okay, anyway, get back. Okay, see, here we have only normal switches only. A dual control switch, you can see that page number 223. It's removed, not part of syllabus. Now, what is here only, a dual control switch circuit with the dual control staircase wiring is removed. Okay, just normal switches only we have. Okay, two kind of switch. Normal switch only means the switch we are using in our house. So, what is a switch? Switch is an on-off device for current in a circuit. Which is a on-off device for current in a circuit. It means, hope you know what is the meaning it is. We can switch on or switch off the circuit. That's the use of this switch means. Okay, we can on or off the circuit. Switch is on. Okay, that's I not explain this again. So two types of switches are there. First one is single pole switch. Two types of switches are there. Single pole switch. Single pole switch means which disconnects only the live wire. Two kinds of switches are there. Single pole switch. Most of the switch we are using is single pole switch, which disconnects only the live wire. Then another kind of switch is double pole switch. You can understand, you can guess what is double pole switch. Means it disconnects both neutral and live wire. Together, both connection will disconnect. So single pole switch means which disconnects or which connected only to live wire. See, live wire only. Single pole switch is connected to live wire. Double pole switch means which connected to both neutral and live wire together. Okay, so together we are using. Now, first again get back to the same case. Why switch should connected on live wire? Why switch should connected on live? So always, see, previously we discussed about fuse. Same way, switch also always connected to live wire only. If appliance is here, always connect switch to live wire only. Okay, the dual pole switch also fine, which extra protection. Dual pole switch is extra protection which should be connected to both live and neutral. But normally, normal switch we are using is single pole only. Normal switch we are using in our house and all single pole only. That kind of switch is connected to live wire only. Okay, that kind of switch connected to live wire only. You can explanation is same. Just imagine if you connect the switch in neutral line. We have connected a switch to neutral line. Okay, here also same will happen. If you switch off the circuit get disconnected, but still that appliances is connected with the live wire. Even if switch off, the appliances is connected with that live wire. That instrument is connected with that live wire. Okay, so what happened? Someone is touching. So see, always connected to live wire means someone is touching or handling these appliances. Even after switch off, there is a possibility of getting shock. So the current will pass through the body. Someone is, see, we are holding like this. The current is reaching here and pass through appliances through our body. It will get disconnected. It will circuit get completed. So current is passing through our body means we get shock. So we can explain both in almost in same way, almost in similar way. Both switch and this fuse, you can explain why it should connect it to live wire. Almost same way. If it is connected to neutral line, both the case circuit get disconnected. But if someone is being contact with the appliances, there is a possibility of getting shock. The circuit should get completed through that person. See, I am touching here. So through me, the circuit get completed. So current will flow through me. It means I am getting shock. So the listen, it's not safe to carry out any repairs or in appliance because of the touching live wire is appliances. The current will pass through the body of the person who finally gets shocked. If someone is repairing, anyway, someone is repairing or directly being contact with that appliances, there is a possibility to get shock. Okay, someone is repairing or directly being contacted with that appliances, there is a possibility of get shock. To avoid that, fuse and switch always should be connected with the live wire. Okay, so you can explain both almost in same way. Okay, this fuse and switch, why it should connect through live wire only? Why it should connect through live wire only? You have to first argue that even after, see, in the case of switch, if switch, even after switch is being off, previous case, even after fuse is melt, the appliances is still being in contact with the live wire. The appliance is still being contacted with the live wire. Someone or some person being contacted with the appliances, there is a possibility of getting shock because the circuit can be completed through that person. If I am touching here, through me the circuit can be completed. It means current flow is there. To avoid, say you want to repair, switch off and touch here, it means still the appliance is connected with the live wire, there is chance of getting shock. To avoid that, the switch and fuse wire, fuse always should be connected with the live wire. Okay, then you can say that some more safety precaution while handling a switch. A switch will never touch with wet hand. It never switch on or switch off with wet hand. Why? When you are touching, there is a possibility that a small portion of the water will pass through the switch and being connected with the circuit. Water is a good conductor of electricity. I can say this properly. Normal water is a conductor of electricity. Pure water is not a conductor, but we are not using any pure water. So water is a conductor of electricity. See, that's actually I say wrong statement. I know it's pure water is not a conductor of electricity, but still I am saying that water is a conductor of electricity. So there is a possibility that electricity pass through the water and get shocked. So there is a small layer may form between our hand and switch through this liquid, through this water. Through that, person may get shock. Okay. See this. Okay. Any doubt, students, regarding this switch? Explain the same way. Explain the same way, almost similar way as fuse. Just go through these two and compare the difference. No, see question paper, there is no optional questions, okay. There are no optional questions. Actually, that's a mistake. There are no optional questions. No options in the question paper. Only 4 chapters only. For 4 chapters, I can't give any options. Minimum half of the units are there. Test paper, which have minimum half of the units, then only I give optional questions. Otherwise, don't expect any options. Till there, no options at all. Okay. Not only for this examination, minimum half of the questions are there, then only I give options. Else, no options. All questions are compulsory. Okay, the heading was a mistake. All questions are compulsory. Okay. So, any doubt, students? Okay, then one more mistake was there. I think that section B, second question, actually 1 and 3 only there. Okay. Actually, there is no second question. Sub question 1 and 3 only. Okay, just write that. Actually, 2 questions together have 3 mark. Okay, so, one more I is added. That's all. Okay, no problem. Just write. Okay. Okay, so students, any more doubts? About this switch? Okay, so yeah. Then one more safety precaution we will make is earthing or grounding. So one more safety precaution. Okay. So any more doubts, students? I think that's a long topic. We need time. So I'm expecting within next class, one more class needed to complete the portions. Thereafter, only numerical. Okay. Mainly we'll deal with numerical. And if you are okay, see after that, if you have any doubt, just answer previous question paper. Okay. Collect some previous question papers. Then you may feel difficulty that few topics are removed, so that's a difficulty. Still, just answer topics. And if you feel as any difficult questions are there in previous question paper, that also we can discuss here. Okay. So difficult numericals and difficult previous question paper questions that we are going to discuss after this. Okay. So any doubts regarding this? See, today just 2 topics only we have taken: fuse and switch. Any doubts? Anybody? Okay, so I'm not taking any more topics. So you can see in next class. Okay, continue your exam. If you are not completed, is to continue your exam. See you in next class. Okay, thank you.